All right. Well, today's gonna mark day 9 of FOP. Last night I mentioned that we were going to do the read and write lesson. After reviewing the curriculum, we're not gonna do that today. Um, because the repo, right, the one that you guys have is the most updated one. So I'm not used to the structure of it yet. I added lesson 10. You guys should have that already. Lesson 10 is the Pygame module. And it's lesson 10 for a reason because after the Pygame module, it switches from objects to something completely different. So before we even move forward, I think it's important we stick to object-oriented programming, finish that off before we even branch off anywhere else. So we're actually gonna do uh Pygame Space Invaders replica today, and then probably Monday and Tuesday. Uh, we're trying to extend it mainly because when I created this lesson, uh, it was an awkward month where we had like 2 days off. Um, so we kind of rested. But now that for you guys have the full month, we can actually take a lot more time and mess around more with objects and classes and kind of get used to it. So uh, if you guys open up lesson 10, it's going to it should have two things. It's gonna have a folder which is assets. This is gonna be the images we're gonna be using for our little game. So you already have all the images you need. These are very simple. I just found it from like one of those uh you know easy photo websites that you don't have to donate anything and have no licenses or whatever. So you're free to use it however you want. And then you're gonna have the README. The README is gonna be uh your guide for the entirety of the project. Everything that we're gonna be doing is gonna be straight out of the README. Um, and the reason for that is because Pygame itself, the module, is not part of the immersive curriculum, right? Pygame itself is its own thing. You can spend weeks, a couple months on it, learning the ins and out of Pygame. There's all these different commands. It's it's really big. It's a very big library, and there's a lot you can do with it. But that's not the point of this class, right? The point of this lesson will be to get more experience with classes and objects and be able to visualize what our objects are doing. And Pygame will allow us to do that. And I think I have that here on the description, right? So in this extracurricular lecture, this is not extra anymore, this is now in the curriculum. We will be discussing classes and objects while utilizing Python module Pygame to further improve our understanding and confidence when working with OOP. Object-oriented programming provides us flexibility in our code, allowing us to create reusable code that can be altered without affecting the rest of our program. Using concepts like inheritance, polymorphism, we are able to create subclasses and override methods in our children without directly affecting our parent class. Imagine having the blueprint to a car that allows you to easily recreate different car types without having to restart from scratch every single time and still have the flexibility to change any features from its parents. That is the power of classes and objects, right? So Pygame is a module that requires Python and pip. Fortunately, you guys should have pip already throughout the install phase. So getting Pygame is very simple. I have two methods here. One's going to be for Ubuntu and one is for Mac. All right, so you're going to open up your terminal, and I need you guys to run either one of these commands depending on what machine you have.
Excuse me.
Uh, what's up, Brandon?
Two things. First, how did you get your README to look so pretty and formatted? Mine just doesn't. It it looks like there's formatting.
Like this. It looks like this. On the top right, you will have a open preview to the slide that has a magnifying glass. Press that, and
Oh,
it'll
cool.
give you the formatted version of what it looks like when it's on GitHub, right? Like,
Sweet. Way
yeah,
better.
yep.
Okay, cool. And then second thing is when I try to run these commands, it says that it's a externally managed environment. So I believe I have to start a virtual environment in order to install Pygame.
You don't have to. Are you using Mac?
Yeah, I am. Whenever I run, uh, whenever I try to use pip commands or Python, it says externally managed.
Hmm.
Yeah, and mine says externally managed as well.
And I think that's a new thing with Homebrew. on Mac, I think it causes that.
Do you know how to start your virtual environment?
I know that I have to do make directory, but then that's where I'm a little unsure of how I should do it. So what's in my mind and what I want to do is I want to create a directory inside of lesson 10 and then install my Pygame in that virtual environment. So
Yeah,
that way I
so all
could
right,
still grab the assets.
try do that then, if you
Uh,
can.
so so that's actually where I need a bit of help. So
I haven't really used Mac. Let me see if I can get you the commands for it real quick. I have
so
not set up a virtual environment in a hot minute. Okay, so yeah, we'll take the next 15 minutes to
So it
try to set
worked.
this up. What's up?
It worked on my Mac. I
are
ran
you,
the command, so
are you using a
let's see. I'm trying to
Apple
figure out
silicone or Intel?
Apple.
Oh, okay.
I'm on a
It's not working.
23 M2 MacBook Pro.
Gotcha.
So you have pip
Website
installed, right?
up.
I have what installed?
You have pip installed?
Yes.
Do you have virtual environment installed?
I believe that comes with Python.
So if you try to do sudo pip install virtual environment, does that work?
Need to do pip3. It says this environment is externally managed. To install Python packages system wide, try
Okay.
brew and
Do you have so you
What
have
version? What version of pip is it? Because I got working on. It says 2.1 .2.4. That says, however, version 24 is available.
I mean you
Are you
can
on
update pip.
24?
You can update if you want. But hey, so your Mac, right? So, like I said, I don't have familiarity with Mac. Uh,
right.
so for us, the Windows users, we're able to open up an Ubuntu shell, and we can even open up our regular Windows shell if we wanted to. Are you able to do that? Do you have two different terminals you can use?
Um, I have terminal and iTerm.
Which is the one that you typically use?
iTerm.
Use your regular terminal.
Yeah, it says externally managed environment. I could run break system packages, but I don't. It says it could really fuck up your computer if you do that.
Yeah. Mm,
I mean, I'll just let me see if I can just do the virtual environment. My confusion is more about how to create the environment where I'm currently at instead of writing out the whole path for it.
can you do brew install Pygame?
I try that and it says it's not found. Oh, okay, now it's working for some reason. Oh wait. No, it says Pygame wasn't found. No available formula.
I did the exact same thing, and I got the same thing. It says no available formula with the name Pygame.
So if I
Yeah, homebrew is new. You guys weren't using homebrew the last time we did this. Okay. So you have homebrew installed, right?
Yeah,
Uh, run this command.
So pip install Pygame.
Here, run that.
run what? Sorry.
Check the chat.
Oh, chat.
Let me put it in the chat too.
Did yours run, Sam?
Mine did
Pip
not.
install Pygame. I just read onto it. It said although if you're using a virtual environment, which is a good practice, you can drop the first part, assuming the environment is active, and just run pip install Pygame.
Okay, try Sam's way. If yours doesn't work, then here's straight from the Pygame documents. They talk about how to install it with homebrew.
Right, yeah, I've actually read this. Oh, I got it. Oh, actually, never mind. Where did that go?
Copy. Put it on there. What is it? This it does.
What's up, Sam?
I posted on Slack, so for Brandon to see, like I put yeah, just I put pip install Pygame, and then it gave me feedback saying collecting Pygame, downloaded, installing packages Pygame, successfully installed Pygame 2.5.2. So
You have a virtual environment running, don't you?
I did. Yeah, that's why there was that error was coming in. Which I don't know what that means, but it was giving me that same error, and then I had to look for a way around it.
And how'd you go around it?
It just said don't put pi in front of it. Just says pip install Pygame.
Okay. So after you installed it, Sam, run that code. If you check the README after it's installed, you need to run the pygame.example.aliens one. It should be the third code there. So after Pygame has been installed, run the following command on your terminal to test it out.
And yeah, I think I have to start a virtual environment.
Does your terminal look like Sam's? He has a virtual environment on his.
Not yet. I have to actually make it first.
Did your window run that small little demo of a game, Sam?
Loud. Excuse my language. That was loud.
I saw it. Yeah, it works.
All right, sweet.
So
Eric,
I'm having a
Joseph?
problem with that.
Okay, what's happening?
So I'm on Windows with the Ubuntu. I installed it and then I tried running that next command to make the window pop up with the game, and I'm getting error while finding module specifications for pygame.examples.aliens module not found error.
Okay, you're gonna have to open up a regular window then. That happened to me last class. I had to run the entire thing throughout my regular window shell. So instead of having all the code for Pygame on my Ubuntu virtual machine, I had to have it on my regular machine. But it's not a big deal. Pygame is not like anything big. It's gonna take up a lot of space. It's very small. You can delete it later afterwards if you want.
Okay.
Uh, before you do anything, Joseph, there is it's different for Windows, I believe. Here. Check the Zoom link. If you mm, do you have Python on your regular computer?
Mm. Yes.
Okay, good. Let's pause the recording. Move forward. So now that everyone has Pygame installed and they've run through the little demo, we can actually go ahead and move on. So if you are able to use your regular terminal like for Ubuntu or whatever virtual machine you have, then use that. If not, then make sure you guys copy the folder of lesson 10 to wherever you're running your Pygame. Yeah, so back to it. Reiterating, Pygame module, not part of the immersive program, right? It's not. I am utilizing it as a tool to help you visualize your classes and objects. Right? I received great feedback after last class. They really enjoyed it, especially for those that, I believe Cody was having some issues with it yesterday, just kind of picturing objects in general and what they are. Hopefully this gives you a better understanding of how objects work and how they differentiate from everything else and the powers of objects. So you're not going to be a Pygame expert. As a matter of fact, the way that this lesson is built, it's all like code along. Like at no point up to the very last part where you're done, are you coding and not knowing what you're doing. I'll have everything here in the README if you wanted to, and you can leave this class and just read through the README, and you'll still have a finished product as well. So all the code is already provided for you. I do recommend as we go through here, I'm gonna give you guys like some time to kind of pull off the side, try the code. The code will be in your README. Don't cheat and try to copy it. Try to do it yourself. And then if you fail, you just can't do it right, then you can obviously just check the code, like what it should look like for it to work. So it's all gonna be here. We're gonna go ahead and code along. But yeah, so getting started. Now that Pygame is installed, we're going to go ahead and create a file within our lesson 10 file. Make sure it's not inside of assets. It's on the same directory as assets. And I want you guys to call this file main.py. Let me go ahead and start sharing. I almost forgot. All right, so you're gonna go ahead and create a new file and call this main.py. And give me a second. I gotta pull up my reference. I'm not going to the reading. I'll stop. This file is what's gonna
In
hold
assets. Sorry.
not in assets. It's gonna be on the same directory as assets. Does that make sense?
Okay.
It should not be inside of assets. It should be side by side with it.
What about for us that have the virtual environment?
Make sure you have the folder assets in that same directory as well. You just need to have access to it. So when you go and use the assets, you're not trying to find the file path of where it's located. If you have it locally, it would make it significantly easier. If not, it's gonna be hard for you trying to find it. Make sense?
Mhm.
Stand by. I should have had this pulled up already. My bad. Okay. Okay. All right. So in your README, you're gonna have a Pygame method cheat sheet. All right. No, it's not what I want. You're actually missing a lot. Stand by. I'm sorry. I do apologize for the technical difficulties we're having here. Let me find it. Okay. Mhm. I'm almost done. I'm sorry. Okay. All right. We can go ahead and begin. All right. So now that we have our little window, the first thing we want to do is we're going to want to import our Pygame module, right? Just like everything else that we've had so far, like the random or the statistics, Pygame is a module that comes with Python. But to even use it, we're going to want to import it into our file. And once it is imported, we're going to go ahead and create a class. This class is going to be called game. And this class is going to hold the overall logic that's going to run the window for our game, right? Within here is where we're going to want to actually create our window. So we're going to define an init method to initialize it. And it's going to go and take itself and nothing else, right? Within this init method, we're going to want to initialize Pygame, all right? So the same way that we're initializing a class, that's kind of how we're going to want to initialize Pygame. So you're going to have to use the command for it, which is going to be pygame.init. And this is going to turn on Pygame within this file, okay? All these commands are coming straight out of the documentation. So like none of this is being made up. If you check here on the README, you're gonna have a nice little cheat sheet. Maybe it wasn't perfectly formatted, but the first command we're using here is pygame.init, and it initializes the Pygame module in your code, right? That's what that is doing. If you want a reference of where all this is being grabbed from, you can find it from the Pygame documentation. They typically have different ways of doing stuff: introduction, importing, initializing. They even give you a small blueprint of what it should look like. So I'm not just pulling this out of thin air. This is straight out of documentation of how it's done. So we have to initialize Pygame before we do anything else, right? Now, that Pygame is initialized, we can start using all the methods that come with Pygame. And the first method we're going to use is going to be the Pygame.display method. So we're going to create a data member, and this data member is going to hold our screen. So we're going to do self.screen is equal to the Pygame display method. So it'll be Pygame.display.set mode, right? The Pygame.display is what's going to create your window, and the set mode method is what tells it what size you want your window to be. So we're gonna go ahead and say it's gonna be 800 pixels by 800, right? Notice that it's a parentheses within a parentheses, okay? We also have this cool other method that allows you to kind of format the name that's going to appear on the top of your window. So if you guys ever, when you guys open up your browser and you open up a new tab, let's say you're on the Facebook tab, on the tab itself, it will say like Facebook, right? So we're able to customize something like that, which will show the name of what our window will have. And to manipulate that, we're going to use Pygame.display.set caption, right? We see here that set caption takes a title as a string. So it's gonna be set caption, open parentheses, and then in here, in the string format, you can input whatever you want to do for your title. We're gonna call this Space Invaders, right? We're doing a Space Invaders replica. This will set the caption in our window. And now the next thing we're gonna want to initialize is going to be a clock, right? So in game development, in games in general, the clock allows you to track the frames per second on your game. So we have to initialize some form of clock. So we're going to do self.clock is equal to Pygame.time.clock. These are all basic stuff that is required for the window to work, right? Straight out of the documentation. Right? Still with me?
Sorry, where was the documentation again?
I'll actually send a link on the Zoom chat if you guys want to use that. There's the docs right there. Hold on, stand by. I'm getting a phone call. I do apologize for that. That was from actually Accenture, what I was talking to you about earlier. So I had to pick that up. But all right, so moving forward. So far we have our clock established. And now that our clock has been established, we can actually go ahead and create our run method. So we have everything that we need. Next, we're going to do a run method, which is going to actually run this object. So we're gonna go ahead and define run. Gonna take in self, and then we're gonna say while true.
You're not sharing screen.
My bad. Okay, can you guys see my screen? Awesome. So we're gonna go ahead and define the run method. I'm gonna say while true, we're gonna want to do something. And within this while loop is where we're gonna hold all the logic of the game. So what's gonna happen is every time that it runs through this while loop, it's going to essentially refresh our game logic and update the status of our game. So while in here, we're gonna say for event in Pygame.event.get. Right now, what is this? Well, everything that happens within Pygame is called an event, right? So every time that our clock is ticking, it's grabbing all the events that are happening on this window. An event can be something as simple as a key press. It can be something as your mouse clicking, mouse movement. It can be checking the window if the X button was pressed or not. It's going to run constantly the entire time that this loop is going, and it's checking every like millisecond what events are happening, right? And by doing this, we're essentially updating our game window every single like millisecond. It's not exactly milliseconds. Games actually run a lot faster than that, but that's just a way of explaining to you guys. But essentially every millisecond, it's going through this while loop and checking if anything new has happened. Has the image moved, right? Have we updated any of our assets? Is the music still playing? Did you click a mouse key? Did you move your mouse? Anything like that, right? By using pygame.event.get, we're receiving a dictionary of all the events that Pygame tracks. And that's how we check for the different events. All right, so we're doing for the event in pygame.event.get. If event.type is equal to pygame.quit, then we're going to want to do pygame.quit. And notice, what does that mean? What does pygame.quit in all caps? Well, that means if we press the X button, right? This is checking for the X button event, and this is actually quitting your game. All right, so these are two different things. Keep that in mind. This is an event, and this is an action, right? So if the event type that we have that we're looping through is equal to pygame.quit, then I want to quit my game. Now, for good measures, we also want to manipulate the X out button on the top right of our window. And how do we get access to that? Well, we're going to want to import another module. It's going to be called sys. So on the very top, we're going to do import sys for system. And this will allow us to manipulate certain things on our window. And we're going to force that window to exit. Right. This is just for double precaution to ensure the window actually closes. If we don't do this, you might have some bugs where you try to press the X button on your game and it won't close the game and it'll run indefinitely. So this is just two ways of ensuring that our game window actually closes. So we're quitting.
Excuse me.
What's up?
So, Eric, are you still having issues with the import not being correct? Okay,
Yeah.
so a solution, which I don't know if this is what we should do in the future, but if you open up, so in the virtual environment, there should be a folder called lib. Open that up. And then you want to open up Pygame, and then there should be a folder called examples, which is where we ran the game, pygame.examples.aliens. You can just put your main.py in there, and then you just import Pygame, and then you run it with that same command, just with main.py instead.
Okay. Gotcha.
I think we need to come up with a different solution in the future, but.
What's going on?
So basically what I think's happening is because we're installing a virtual environment, Pygame is not a system-wide package. And therefore, whenever we try to import Pygame, it is causing an issue because it's not in our Python directory. So without going into our system files and appending a new path for Python, we can just put our code today inside of the examples folder within Pygame, and then we're able to import all the classes and methods and whatnot.
So for now, you're good.
For now, we're good, yeah, but for anybody using a virtual environment, that's what we have to do right now until someone smarter than me comes up with a new idea.
Yeah. Okay. All right. Sounds good. So can we move forward? We good?
I'm good, yeah.
Okay. All right. So back to this, right? We created the functionality to be able to exit our window. now that's complete, we can go ahead and while inside of this while loop, you're going to what you call it, come down after the for loop. We're going to do Pygame dot display dot update. Right. So every time that we run this while loop, we're gonna want to update our screen. It's pretty much just like saying refresh the window. So in case any actions that were done, for example, if we have the spaceship and we move it to the right, every millisecond we're moving it, then every single time that it runs through this while loop, we also want to update what's on our screen for it to reflect the changes we have made. So by using the pygame.display.update method, it's going to refresh our window. And then afterwards, we're going to want to set the clock, our frames, to 60, right? The clock that we established in the init method, we're going to call that self.clock, right? And then we're going to do .tick, and this will set the frame rate of your game to 60 frames per second. Okay?
So what would you do if you wanted to make it so that like people could increase their frame rate?
You would just change it here. Oh, I mean, if you want to change it, I mean, you could
Yeah, like-
use. We'll get to that later of how to manipulate for different things.
All right.
But it's because it's such a low impact game, you don't need any crazy frame rate. 60 is more than fine. So ideally, I wouldn't want them to change their frame rate because it's it's not like you're running Call of Duty on this bad boy.
Yeah.
All right, so 60 will work just fine. Now, if we did this correctly, this should run a window for us with the caption Space Invaders. We have a clock that's tracking the frame rate. We have the size of the window, and then we're tracking when we can close it. So this should, in theory, if I did this right, run a blank window. So once the class has been established, we're going to actually instantiate our game, and we'll call this my game is equal to the game class, right? This is going to instantiate an object called game and save it to the my game variable. And once it's created, we're going to do my game dot run. Now, if we do this right, if you run your window or your file, it should open up this little window for you. A blank canvas of your Pygame file. Right? Does everyone have this so far at least? I'll move my window so you can see the code. The code that we wrote so far is just so we're able to display an 800 by 800 window with Space Invaders at the very top as a caption, with 60 frame rates and with the ability to exit out. Right? That's what we're doing here on line 16, 17. We're checking if we press that X button, and if we did, then we want to close the window. Does everyone have a working game window? Who does it?
Mine opens and then immediately closes.
Go ahead and share real quick.
Game has no attribute run. The fuck?
So you initialize, you set your game window. Okay. You set display. You got the clock. You on your clock, it's open and close parentheses. It's a method, brother, on line 10. So it doesn't have any frame rate.
Oh,
Try that. Run now.
there we go. All right.
Cool. Awesome.
Thank you.
No problem.
Import issues that the Mac users are having now. So
Okay,
That's-
so you gotta put your main.py inside of your examples folder. So, so open up VNV or whatever your virtual environment folder is. Then you should have a lib folder, open that. Then you have a Pygame folder with no dash, it's just straight up Pygame. And then you'll have examples, and that's where you want to put your, whatever you're naming your file. Do you see that?
I don't, so, huh.
Do you see the virtual environment folder that you have?
Share the window so we can see.
Okay. Is it in terminal? Hold on.
So I'm just using VS Code.
Okay, let me share my folder.
Hey, the rest of y'all take a 10-minute break.
I'm seeing a surfboard.
Favorite spots. I don't go surf that, but that's crazy. Okay,
Okay,
right
so
here.
yeah, so if you are currently not in your virtual environment folder. So if you look where it says Pygame, that's the issue right now. Open up terminal and then navigate to lesson 10.
LS seed.
And I can't see your terminal right now.
Oh, let me get it.
Did you share your VS Code window or did you share your display window? Because
My
sometimes
display window. Yeah, desktop one. Oh, yeah. No, it's there.
Okay, so yeah, navigate to your lesson 10 folder.
Okay. So CD FOP.
Okay, and then now you want to type Python 3 dash M. Sorry, Python 3 is one word. Dash M. Mike, M for Mike. And then VENV. And then whatever you'd like to name your virtual environment. So like my environment or something like that. This will just be the folder.
And then cool.
Okay.
And then enter.
Enter. Yep. And then now you want to install Pygame.
Okay, enter here. Oh shoot.
So
How did I do
so
that?
go to the README in lesson 10 and then copy the Mac method without dash dash user because you won't be able to use the user command or the user argument because it's a virtual environment. Right. Oh, I'm sorry, you have to activate the environment first. So go ahead and in your terminal, go ahead and type source and then my environment /bin bin
/
/activate. And now we should see your environment start. Okay, good. Now run the other command. So just hit up arrow twice. And then install. So now what you want to do, I understand we're supposed to be using terminal a bunch, but just open up your VS Code now. And so that we can see it as well.
You're really good at this, Brandon.
Yeah, I would have not figured this crap out. All right. Let's see.
Okay, so now if you open up my environment, now you have a lib folder, so open lib, that's bin. And then Pygame with no additional stuff. And then examples. Do you see examples just below docs? Nope, it's at the top. We're looking for a folder. So this is all of the example games for Pygame. You just want to create a new file in there called main.py.
Just type in main.
Right click examples. New file. And then type main.py. Okay, and now you can like type in all the code and whatnot, or just copy it. And then if you ever want to run the game, go to the README. And then do you see where it says Python 3-m pygame.examples? So copy that. And then you can paste it into terminal.
But you would switch aliens to main.
Right, main.py, yeah. And then you should get the Space Invaders window popping up.
All right, let me see. Yep, window popped up.
Good.
We're all good.
Okay,
Yep.
awesome.
Let's go.
I'd never figured that out, man. There's no way I would have figured that out. But
Yeah,
cool.
okay.
All right, Joseph, you there, brother? Once Joseph comes back, we'll begin. I kept the recording on just so we can see what was happening for future references. Joseph, are you back? All right. Well, just to recap as he comes back. So up to this point, we imported Pygame, which has allowed us to use all the different Pygame methods, right? We declared a class called game, right? And this game object, by initiating it, it will run the certain methods. One method being the run method, which will take the data members and create this window for us, right? We initiated a while true loop, which allows the game to continue running, never ending until we press the X button, right? Therefore, triggering the pygame.quit event. And because it triggers it, thanks to our if check on line 15, the moment it triggers the X button, then we quit and exit out from our window, right? That there is the logic for that. And then every time our loop goes through, it's updating the window for any changes that happen, whether you move your mouse, whether you move anything, any of the assets, whatever, it updates it, and then it checks the framework. I'm sorry, the frame rate. Right? Pretty straightforward. If we go to the README, let me go and share. On the README, what did we use? We use the init method, right? It initializes the Pygame module in the code. We set the window to a specific size, right? The X and Y to 800. This holds our screen. And then we have some other methods here, which we're gonna get to in a bit, right? So now that we have that, next thing we're gonna want to do is add a background to our screen, right? Right now, it looks pretty bland. It's blank. There's nothing on there. Well, we're going to create what Pygame calls a surface, right? And the best way to visualize this is to think of it as what you call it? As layers, right? As a pancake. The way Pygame works is that it uses surfaces or essentially a layer, and it stacks things on top of it, right? Whenever you go and you run all the images on your run method, the first item that you display on your screen will be the thing on the very back, right? As soon as you display something else, it'll be on top of that object, and so on and so forth, right? Almost like a layer. So it uses the term surface. And now we already displayed the mode. I'm sorry, the display. We set the mode, but now we want to create a surface for it, right? So we're going to declare a surface within our init method. All right, so in our init method, I need you guys to add another data member. I would just do it down here. Make like a comment that says surfaces, so you're able to distinguish what is and what isn't. And then we're going to declare a new data member. This is still within the init method, so we can still, no matter even make all these spaces, this is still another data member. I'm going to call this our space surface, right? This data member is going to hold a surface. So we're going to do pygame.surface. It's essentially creating a layer that we can put on our screen. And because it is going to be the background, we're going to set it to the same height and width as our window. So pygame.surface, give it its measurements. Now that we have the surface, well, we're going to go ahead and add it to our screen. So down
Why
here,
are we using double parentheses there? Why does it not accept 2 arguments? Why does it only
it takes multiple arguments, right? But the first argument it takes is the
a tuple for
yes. So let me show you. Display, for example, like the set mode. When you go here, there's different argument it takes. The first argument is the size. So it's a tuple, right?
Okay.
Then it takes flags, depth, display. You're able to do multiple like other things here. But the very first one that it takes is a tuple being the size of your window. All right. So like I said, I'm not bringing these methods out of nowhere. This is straight out of the documentation. Okay.
Okay.
All right. So we create that surface. Essentially, what we did very similar. It's kind of like the display. We created a display. There's going to be one display though. So to create something else on top of that, we have to create a surface, right? So we are creating a layer, and we're going to set this layer on top of our surface, all right? And the way that we're going to do that is going to be by coming down between the pygame.display.update line and between the for loop that checks events. This is where we're going to put all our surfaces. Any surface, any image, we're going to do it between these 2 groups. So just to add some kind of layer, surfaces, images, functionality. And then here it's going to be screen updates. So our surfaces are going to go within this little block, right, inside of our while loop. And we're going to do self dot screen, or essentially we'll do space surface because we're grabbing the surface that we already created, and then we're going to add it onto the window. And the way to paste something on top of our display is by using a method called blit. All right, so dot blit. The first argument it takes is the image you want to add. And the second argument it takes is where you want to essentially put that image at, right? So we see here in the little example, the first one is the coordinate. My bad. The surface itself, and then the coordinate of where we want to put it. So within here, we're gonna do pygame.image.load. This will load our image onto this surface, and it's going to be by finding the file path of your assets, right? So for me, it's gonna look something like this: assets / and then I'm gonna add the outer space.png image. Right, this is the location of where the image I'm trying to load. That's going to be the first argument I'm going to pass in. And the second argument I'm going to pass in is going to be a tuple, once again, of where I want to put my image. Now, the way that images are placed in Pygame is by manipulating the top left corner of your surface or image, right? So where do I want to place this image at? I want to place it at the very top left of my window. Well, if you guys are familiar with how your pixels work on your screen, from left to right, 0 starts to the left, and as you move right, it's increasing. It's x-axis, and then the y-axis is going to start from 0. As you go down, it increases, right? So if I want to place the top left corner of my image at the very top left corner of my window, then the location I want to place it at is going to be 0, 0. Does that make sense to you guys? Now, if I want to, actually, I'll wait for that till later. But essentially, this should place the image on my surface. But now that it's on my surface, now I have to actually draw the surface onto my display. And to do that, you're going to do correction. I take that back. Ignore everything I just said. Ignore everything I just said. I don't think this is gonna work. Let's check it out. No, it's not gonna work. Okay, it's not finding the file path. So this happened to me before. Unfortunately, I have to copy my exact file path of where my image is at, and it's not working. Why is it not working? Well, I skipped a step. So I'm placing this on my surface, but my surface isn't on my window yet. I do apologize for that. I overlooked the step. I have to place my screen on here, right? My surface on my screen. So I'm gonna do self.screen.blit, and then I'm gonna add the surface on my window. Right? So I place the surface on my window, and now that the surface is on the window, I'm gonna place my image on the surface. Does that make sense? Or did I confuse you guys? Right? So I told you guys we have to essentially draw it on our window, but you can't just draw the image directly on a display. You need to draw it onto a surface first. So the line 25, it's putting it on the surface, but the surface isn't on my window yet. So I have to add this line right here where we're going to place the surface on top of my display window. And now
Okay,
if you
so we're trying to use blit on the screen of the program, and then we are using blit on our space surface.
correct, yes. So you're doing it.
So we're layering it. We're adding like a
Yes.
primer, like a paint primer, and then we're painting it.
Yes, that's exactly what we're doing. Right. I might have gotten you guys confused by skipping the step. We're doing the exact same thing, but first we're gonna layer the space surface on top of our display. And then now that the surface is there, we can layer the image on that surface. So we're layering it. Right. We can't just place paint without primer because it's gonna peel off. Make sense?
Yes, but can you stay there? Cause mine is not working at the moment. I think
Sure.
it's my file path.
It is your file path more than likely. I have to copy the direct path, and if done correctly,
Oh,
it should
okay.
give you something similar to this.
Yeah, mine's, I tried doing relative, I think.
Now, what if I do 100 by 100?
Yeah, that worked.
When I change it from 0, 0 to 100 by 100, we see now the space image, it's at a weird starting point, right? Because we're manipulating that top left corner. This is the top left corner of the image. We shifted it 100 pixels to the right and 100 pixels downwards. Right? That's what we're doing the 0, 0, because it's manipulating that top left corner of your image. Now, what if I did negative 100 and negative 100? If we run that, oh, our image is actually a lot bigger than I expected. Let's do negative 400 and negative 400. There we go. We see here that the bottom right side isn't being covered because by going negative, we're pushing it outside of our window. The way the X's and Y, the X and Y axis work is that from left to right goes positive, from top left to bottom left, it goes negative, right? So this is your Y axis. If you go negative Y, it's going to go up. If you go positive Y, it's going to go down. And then for your X axis, if you go positive X, it'll go right. Negative X will go left. Right, and it will move so accordingly. So that's why that is 0. And it should have this image. Does everyone have this?
Yes.
Awesome.
No, I got an error. Even
Let's
with
see it.
copying, even with directly copying the path.
Let's see.
Did you do relative path or?
I need you to put forward slashes. So all your entire path has all backslashes. Change them to forward slashes. I don't know why it works this way, but in certain words, like right here, if you see on that A, you see how that's slightly highlighted? It's like yellowish.
Yeah.
It's because it's taking it as if it's a Unicode.
It's escaping it?
Yes. So we have to use Pygame.surface. Okay, there's something wrong with this Pygame.surface. You need to do capital S for your surface. Lowercase s isn't a method. The method, unfortunately, is written with a capital S right here on
What line is that?
13. There you go.
Hey,
Cool.
we gaming, boys.
Let's go. All right. So
But mine's not working either now. So
okay, let's see, Sam. Let's see.
yeah. All right. Let's see.
Here, I hope your assets are within the example file. That's probably what you're going wrong.
Well, he can just
Yeah.
copy the direct path and that should still work.
Okay, well, we'll see. But let's share.
Cause even if you have examples in the proper folder, it's gonna not work with the relative
says-
path.
No module named Pygame. Run it.
I was using the terminal, but yeah.
Okay, so
Using the actual terminal, but
run the
trying to
terminal
run
that
it.
has the environment turned on.
Well, you could also turn the environment on here if you want,
Yeah, you
but
can.
so you just have to type source. Or wait, you have to navigate to it actually, sorry. You gotta go to lesson 10.
So lesson 10.
You can right click lesson 10 on the left hand side and then click open with integrated terminal. There you go. Now you should be able to run the source command. No, yeah, you still have to turn the environment on. So right now the environment is off. So you have to use the source command.
Source my environment /bin/activate. You have to
Right.
activate the virtual environment.
Source,
Sorry, one more time. Source.
my environment. So that's the file, right? You created my environment
Mhm.
/bin. No, forward, there you go.
Then okay.
/activate.
Activate. Okay.
Try typing ls. Okay, so you're not in, for some reason, you're not in less than 10. Go into less than 10 now. Now try the other command to, you can just hit up twice. There you go. Okay, now you're in it, so now you should be able to run. But I think you have to, I actually think you have to type it in, because it's
Yeah,
gonna,
type it in.
it's gonna default to something else. So from your readme, copy the command and then just change it to my.py.
Main.py.
Main.py.
Main.py. Okay.
Okay, so it's not actually running it because I think that -m is unnecessary. Oh, you're missing Python 3, sorry.
Oh, Python 3 first. Oh,
Python, yeah.
yep. I see it.
Or if you're aliased, it would be Python. There you, .py.
Okay. Okay, so it's working though. We can run it here, but there's an
He's
issue
using
with
He's using relative path. Right click the outer space.png on the left hand side.
Sorry. Okay, right here.
Yeah,
Yeah.
right click that outer space. And then copy path. And then delete all that and paste. Oh, I guess it was his direct path. That's weird.
Try run it again just in case.
Sorry. Yeah.
Not there. There you go. Alright, hold on. Space uplet.
Function
Position 2.
missing.
Your 0 is in multiple parentheses. It should only be take out one of those.
That one's good. That one's good.
It should be 0,0. It's 0,0.
Your path has another parentheses as well. So after your file path, you have two parentheses. It should have one.
Yeah, one parentheses, then a comma.
Yeah. Brother, after your whole file path, you need to take out one of those right here. One of these needs to go.
Parentheses?
Yes, take
I'm
out
not
one.
seeing it. Okay. Okay, yep, now I see it. Okay. But this is kind of highlighting right here though.
Yeah, so put another one on the far right. It should work now. There you go.
Yeah.
We're good.
All
Let's
right, cool.
continue.
Small little syntax issues, no biggie. All right, moving forward. So let's recap, right? We wanted to create an image, but to have that image on our display, we need a surface that we can put it on. So we create that surface up here on line 13, right? So using the Pygame.surface method, set the size of it to the window because we're trying to cover the entire thing. we blit that surface onto our window. And now that the surface is on that window, we can actually put the image directly on that surface, right? We can't just display an image on display. It needs a surface to sit on, right? It's like putting a cup on a coaster to put it on your table. Make sense? The table being the display, coaster being the surface, and the cup being the image. All right, cool. So we now created the surface for space. We loaded it up. Now we're gonna want to create our character.
Can you go
Right, so
live or share?
Yes, sir. Thank you. So we create the background surface. Now we want to create our character. So after create your main.py file with our template, you create a separate file and we're going to name it hero.py. It can be whatever you want. Hero.py, spaceship.py, it don't matter. So you're going to create a different file within the same directory that you're working with. If you're in the lesson 10 one, then create it next to the main.py. If you're one of the Mac users, create it in the example file, right? So it's gonna be ship.py for me. I'll just call mine that. This is gonna be everything for my ship. Now, in here, once again, we're going to go ahead and import Pygame. So we can use the methods. And then we're gonna define our spaceship class. Now, like every other class, we have to initialize it. So define init method is going to take in self. It's going to take an image and an X and Y coordinate. So whenever we create the spaceship object, we'll immediately pass it the image. So it has it as a data member, and then we're going to pass it where we want to create this image at, right? Those are the two data members we're going to take. Within here, we're going to create a data member called space ship surface. We have to call it surface for some syntax reason. I was having issues by not putting surface in the name. So make sure you put surface in here. I don't know why it was just being weird the last time I was doing it. So whatever you call it, just end it with surface. And in this data member, we're going to save our image. So we're going to do pygame.image.load, and then we're going to pass in the image that's going to be given as an argument whenever we instantiate this object, right? So whatever's passed in here, it'll be added to the image.load method and save it into our data member. Right? Now, the next thing we will do is when it comes to assets like, you know, whether it's an alien, whether it's your hero, all of these small little things that we're going to be adding, we're going to want to create a rectangle, right? If you start diving into game development, you're going to realize that almost everything are rectangles. And the reason why is because we use the rectangles for collision, right? Collision detection. So if you guys ever played a game and you got shot like 2 feet away from your head, but somehow they got a headshot on you, that means they had, you know, crappy hitboxes. The rectangle around your avatar was absolute trash, and whoever programmed it wrong. The rectangle is going to allow us to create something of a hitbox for our images, and these rectangles will also allow us to better manipulate the image on our surface, right? It's going to be very hard, especially if you have a very abstract image, right? Let's say you had like a slime, you have some RPG game, you know, typically whenever you play these MMOs, what are the level 1 monsters? They're like slimes. Now imagine the slime and trying to place such an abstract image onto your screen with no real shape. Well, we use rectangles to better able to manipulate that, right? And Pygame uses that too. So you want to declare a data member called self.rect, and it needs to be called rect or it won't recognize it. And here we're going to do self.spaceship surface. We're going to grab the surface we created and we're going to wrap it around this rectangle that we're creating. So we'll do get rect. So we're calling the spaceship surface, and then we do dot rect around it. And we can give it some form of position. Now, how does this work? Oh, yeah, rect position. Your positions is going to look something very similar to this. And how you call it, right? How do we manipulate this rectangle? Well, here's a little picture of how it works and the different commands. You're able to manipulate a rectangle using top left, top right, bottom left, mid bottom, mid top, center, mid right, mid left, right? All these different commands is how you're able to manipulate that rectangle. Well, we want the spaceship to appear at the very bottom of our screen, dead center, right? Like the Space Invaders game. Well, we're going to want to manipulate the mid bottom of that spaceship so we can place it at the halfway point of our screen. So because of that, we're going to do mid bottom is equal to X and Y. This is the syntax. You can check the documentation if you're wondering where I'm pulling this from. Let's actually do that. Up here on documentation, if you go to rect, it'll show you the different rect commands. If we go to the where is the get rect? Is it on the surface? Here it is. If you go to the surface one, the surface has a get rect, which gets the rectangular area of the surface. And then it takes different arguments. You can pass the keyword argument values to its function. Here we see an example of like using center, and they center it at 100 and 100. It creates a rectangle for the surface center at a given position. That's kind of what we're doing here, right? So we're pulling the surface we created, which holds the image, and then we're wrapping it around the rectangle and setting it to whatever X and Y coordinate we pass in. Cool? Now, for simplicity, we're going to create a method here, a get method. It's going to be define get position that will allow us to manipulate this later on much easier, right? And all it's going to do is return a tuple that holds the rect X and the rect Y, right? We're not manipulating the X and Y directly. We have to manipulate the rectangle now. All right, that's one thing I want to point out. The moment you wrap around your object or your image around the rectangle, the way you manipulate that picture is now through the rectangle, right? Because the X and Y axis was saved into that rect. So if you want to move it, you have to use self.rect. This is how we manipulate now, using the rectangle, right? We're doing the get position to allow us to better update our image later on during the functionality process. Okay? Now, we're going to create a draw method, right? The same way that we drew our space surface onto our window, we're going to give that functionality to our spaceship so it's able to do it itself. So we're going to do define, draw, self, comma, screen. So if you guys remember from the main.py, what did when we blitted this, we had to pass in an image, right? Well, our ship, the image is saved inside the surface, so we can just move and add this the surface on here, or essentially our screen. Right? So we're going to use the screen that we're going to pass in here, and we're going to blit onto it, the surface we created. And then we're going to place it at whatever the rectangle we dictate. All right, same functionality we did in main.py, right? we got the screen and we blitted a surface onto it and set it at location. We're doing that here. But we already did this line 25. We did it at line 6. We loaded the image onto the surface with the rectangle. So all we have to do is just blit the surface onto our screen. And then the X and Y axis, well, it's saved within our rectangle, so we can just do self.rect. And this would draw our image onto our screen, right? Now, let's go ahead and draw this bad boy. We're going to go to our main.py, and at the very top, we're going to do from ship import spaceship, or whatever your file is called and whatever you call your class. From whatever file, import the spaceship class. Right? Now that we have access to the object, or essentially the class, because it's not an object yet until we instantiate it, we want to actually create that object and instantiate it. So we have our surfaces here. I'm going to do spaceship section, and I'm going to do self.spaceship is equal to, and then I'm going to call my spaceship class and create it. Right? And what do we say?
Why are we, so we've been learning to use private methods. Why are we
you
do
can
we just
if
not
you
care?
want.
Okay.
We care. It's a thing, but this is just for us. I'm just for
Okay, no
simplicity's
worries.
sake.
Okay.
Pygame and all these methods, as you might already figure out, it's a lot. So I don't want to make it more complicated and make everything a privatized data member and make you get it in that manner. It
Okay.
would just add more simplicity to it. So, let's not do that right now.
All good.
Right? So we're gonna create our spaceship. Well, what does spaceship class take? Well, we remember it takes in the image and an X and Y axis. Well, what's our image? We're gonna get the direct path to our spaceship. I'm gonna add that as the first argument. After that, we're gonna put comma. And then we're gonna pass in 2 more arguments, one being X and one being Y. Well, I want to set this on the middle of my X-axis. Well, I know that my X-axis is essentially the width. So if at the left it starts at 0, the far right is 800. I know that my center is 400. So the X-axis is going to be 400. Now, I want to place it at the very bottom of my screen. Well, if you guys remember, the rectangle, we're manipulating the mid-bottom. So we essentially want to be able to get the very bottom part of that spaceship. And we can do that by doing 800. Right? So this is what it looks like. Self.spaceship is equal to, then you create that object, passing the 3 arguments we gave it, which is an image, the X-axis, and the Y-axis. Right? Once it passes in, it grabs that image that was passed in there, it saves it within here into pygame.image.load, loads it onto a surface. That surface is then given a rectangle, right? It takes the X and Y passed in to manipulate the position of that rectangle. And then we're drawing it using this method, but we haven't called this method yet, right? So we're gonna have to call it now. Now that a spaceship is created, we're actually able to draw it. So back into our while loop, right? If you guys remember the section that we said where we're going to draw everything, within here is where we're going to go ahead and draw it. So right after the space surface, draw spaceship. In here, I'm going to do self.spaceship.draw. And what does the draw method take? It takes in a screen. Well, what screen do we want to draw it on top of? Take a guess. Any guess?
The surface, space surface.
The space surface, correct. We're gonna want to draw it on the space surface that we created before. Right. This is why we're also placing it after the space surface image. So whenever we draw the image of the spaceship, is not underneath the space image. Right. That's where we put it afterwards. So inside of here, we're gonna pass in a screen. The screen that we're gonna pass in is self.space surface. Right. That's what we created earlier, if you remember, our space surface. Right? So if done correctly, you should be able to run your code, and then you should get something very similar to this. Let me go ahead and move this out of the way for you.
I'm having an issue, no module named ship, but I'm not really sure why that's happening.
Is that the,
Same issue.
it's probably because it doesn't find it. Where is your file?
Oh, it's actually, I think it's because, I actually don't know why.
Main.py.
My,
Sorry to bother you.
what happened? Sorry?
No, I was asking if you could full screen the main.py because like the text from the right side like is kind of off, and I wanted to make sure that mine was right.
If you're having issues importing the module, the best way of avoiding all that is just copy all the code from the ship.py and post it on top of your class game within the same file. That way you don't have to import it and deal with any import issues because of your Mac stuff. So let's just
Okay.
skip that and just put it all in the same file. I'm doing it this way to avoid confusing you guys having multiple classes of one file. But if it's not gonna work for you, then just put it all in the same file. It'll still have the same effect. I was just doing the separation of concerns to avoid you guys getting overloaded with so many classes on one file. Make sense?
No, that makes sense, yeah.
Full screen the main.py screen. I just want to make sure that the spaceship that I'm loading is good to go.
Yeah, they should have everything right here. You load up the spaceship.
100. Yep.
So notice we are creating a object inside of this class. So this class is having the ability to create objects.
I think I got it.
Okay. All right, everyone good? So what did we do? We created a whole spaceship class, right? All the functionality that this class has is the exact same thing that we did here for a space surface, right? We created the surface, we loaded an image into that surface, right here on line 29. Right, we blended both the surface and the image. So same thing, but we did it all within the spaceship class. So whenever we actually instantiated the spaceship, all we had to do was instantiate it and then just call the draw method. All the functionality for that was added within the class itself, right? Essentially, we could have done all this in here too, but we just separated the code and gave the spaceship its own functionality. Cool? All right. So we isolate our hero code by creating our class in this individual file. For our hero to properly work, we want to ensure he is able to take as arguments an image and its X and Y coordinates. The image will be used to declare the surface of where he will be working on. Afterwards, to be able to precisely manipulate our spaceship and to be able to track collisions, we need to surround our hero with a rectangle. Think of it as an imaginary box that surrounds the perimeter of our ship. After we create our spaceship, we use the draw functionality to blend it into our screen. Now that our blueprint or class for our spaceship and hero has been created. We can draw it on our screen. A small little reminder of how the pixels work. Cool. We imported it, and this is what your code should look like for the most part. I think it had a different, let me see, why is that different coordinate? I think it's because of the size. Nah, okay, this should be good. It looks pretty spot on. But yeah, so that takes care of that. If done correctly, when our main.py runs, it should open up a game window with our spaceship dead center and a cool looking space background. Now it's cool and all, but our spaceship doesn't do anything just yet. So let's add some functionality. The codes here we get confused, but we'll code along together. So we have the images, we have a background, but let's make this bad boy actually move. Now, if you recall, at the very top of this while loop, we had a for loop that checked the different events that happen, right? So we're able to essentially do things because it's checking for key presses, mouse clicks, mouse movements. So we're going to go ahead and create some kind of action that we can manipulate with our keyboard. So right below the for event loop, not within it, just below, I want you guys to do keys is equal to pygame.key.getPress. Now, this method, what it is doing, it is going to return to you a dictionary of all the keys that are all the keys that are actively being pressed at that moment. So every time our game loop runs and it does its update check, it's going to grab that dictionary of keys and show it to you. Now let's see how that looks if we actually print out keys. If I run it, you see it's just printing out constantly. It's a nonstop list of everything that's being printed out. It's an update of all the keys that we have. So every time it runs, that's how fast the game is running through this loop over and over and over and over again. It's grabbing all the updates, and every single time it loops through, it's grabbing all the key statuses, whether they're true or false. If it's false, that means they're not being pressed. If it's true, then they're being pressed, right? So we're printing it out. Now, we want to be able to grab specific keys. So there is actually a list in the documents to figure out which key is which, but I'm gonna give it to you. We're gonna want to check if either the W, the A, S, or D keys are being pressed. So we're gonna do if keys, which is a dictionary that we're getting back. We're gonna use bracket notation, and we're gonna grab pygame dot capital K underscore A. This means that you are pressing the A key, right? So K for key, A for the A key, right? We're going to want to do something. So we're going to want to do move, right? We're going to want to move our spaceship. If it's the D key, then we want to move down. If it's the W key, we want to move up. I'm sorry, W is left. No, W is up. D is right. A is left, and S is gonna be down. Sorry, I'm kind of dumb. All right. But let's check it out. What does this look like? If the key is A, I want to print out. I want to print it out. How does that look like? Let's run it. So here's my terminal, and then here's my window. While I'm in here, I'm gonna go ahead and press A. And as you see, it's updating. As I'm holding it, it updates, right? It's not how many times I pressed it, because it's running every single time. It's checking if it's still pressed or not. So as long as I'm pressing it, every single time it goes through this loop, it's gonna say true, 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 true over and over again until I let go and it turns into false. Right? That's by pressing the A key. So we need to add some functionality to the spaceship. I'm able to manipulate the A key. I want to check if keys is equal to Pygame.k underscore D. We'll do pass for now. I also want to check if the key is equal to W. Let's pass. Or if keys is equal to S. And then pass again. So these 4 ifs will check for all 4 of these keys. Now, every single time that this is true, I want to do something. Well, let's go back to our spaceship. Let's add that functionality within it. We're able to grab the keys, but now we have to actually make it move with those keys. So we're going to define a new method at the very bottom of our spaceship. It's going to be called move. It's going to take itself, and then we're going to pass in a direction. Right? You guys already know where I'm going with this. So if the D key is being pressed, then we need to call the move method, pass in the direction we're moving, and actually make it move. This is going to be a nice little break for you guys to see if you can code it. I'm going to start you off. If direction is equal to A, then I want to move left, right? So how do I manipulate the placement of my ship? If you guys recall.
We would want to change the rectangle to like -10.
Correct. I want to shift my rectangle. So if the direction is equal to A, then I want to do self.rect. Now, what is A is supposed to be my left. So am I moving the X or the Y axis?
The x-axis.
The X axis, right? X is left to right, Y is top and bottom. So I'm going to want to move my X axis and shift it by a certain amount, right? If I'm pressing the D key, I want to move my X axis and add to it. If I press the W key, I want to move up and shift my Y axis to a negative. If I press the S key, I want to shift my Y axis and move it to the positive, right? Because Y, remember, down is positive, up is negative. That's just how it works. Don't get confused. Cool? Time is 7:19. We will reconvene at 7:35. Take a little break, go use restroom, and then try to code this. So don't forget, you have to do this. But after you give the movement to this spaceship, then you actually have to do something here. So what do you think you're going to have to do? You're probably going to have to call the self.spaceship.move method, right? And then pass in an argument, which is going to be the direction. So take the next 15 minutes to use restroom real quick and then code it out. Can you hear me?
Is there?
I was talking to myself. All right. So let's go ahead and come back. Who wants to go ahead and demonstrate I would like to see the person that got the farthest. Anyone here feel comfortable? Did they get most of the mobility done?
I think so, unless someone else wants to share. Alright, is everybody able to see it? Okay, so, I was unable to really lock in the boundaries, but it's getting better, so I can go up. I'm also keeping track of my X and Y. Can go up. And then I'm still working on getting, S to work. But it's just a bunch of if statements, and I think my A is broken. Yeah, my A breaks if I go too far to the left. And the way that I did this,
Yo, what is that spaceship, bro?
it's a new one that I imported because I wanted to use a cooler one.
Yeah.
I just gotta get rid of the background. So basically, for the movement of the ship, if a key is pressed, I want to, self.spaceship move with the key. And I'm passing that into my move function within the spaceship class. And then, if direction is equal to W, this is where the boundary comes in. So, if it's that key and the, border of Y is less than or equal to 800 and it's greater than 5, the idea that I'm trying to get is, if I'm at the edge of the map, don't move anymore because I don't want to move off the map. And this part's super confusing for me personally, so I'm having a really hard time, or it's taking me a long time to do it, but this is how I handled it. It started becoming easier when I printed the Y and X coordinate for each step, because then I'm able to see, okay, if I hold A, it stops at X equals whatever. And then I can input that in to the code.
Sweet. All right. Let's see your thing move. How far does it move when you actually run your game?
Did you not see that?
Yeah, just move it all the way on all the edges. Let's see what it actually look like.
So, if I go all the way to the top, it's just gonna, Y equals 0, but then I can't use S anymore because I don't have that. I don't have the, if statement, correct?
Oh, okay.
So it works over here. Oh, I went too far. Okay, so as soon as it hits 800, it stops working for D. So that's where, if I set D to 795,
I would do like 750.
750, that'll,
Yeah. It might be a little bit too much, but we'll check it out. Yeesh. Okay.
did I use the wrong key? Oh,
Maybe.
W's the key that I edited. See, this is what I'm saying. It's really confusing.
It's okay.
So here, so it stops. Yeah, I'm unable to move after that with the other keys
Yeah.
or with S.
All right, go ahead. Stop sharing. We'll walk through it. Before I continue, I did have this picture up. I'm just going over it for just the record for anybody else that does watch this video and is confused with the X and Y axis. I just want to make sure I have it on the recording. So here, the small little diagram, this point right here is going to be the top left of your screen, and it's going to be the 0, 0 axis. The first 0 being X and the second 0 being your Y. This line right here, the very top from left to right, this is your X axis. As you move right, your X increases. As you move left past the 0 right here, your X decreases. And then for your Y axis, it's going to be the left side of your screen. Positive Y will bring you downwards, while negative Y will take you up. So anything less than 0 will take you outside your screen. to the top left or the top in general, right or left. So this is kind of what your X and Y axis look like on your screen and how to manipulate it. Cool. All right, so back to the code itself, right? So we were coding our ship. We did if direction is equal to A, well, then I want to do something. But just like Brandon mentioned, I don't want to go out of my screen. So I'm going to do another if statement within here. I'm going to do if self dot rect dot x is greater or equal to 20, then actually this is going to be my, I'll do my A first. If self.rect is greater or equal to 20, then I actually want to move it. A is to move left, right? So that means I will only move left if my X is greater or equal to 20. Anything less than that, then I start pushing to the left side of my window, right? But if it's above that, then I want to move 5 pixels, right? Now, to move right, elif direction is equal to D. If self.rect.x is less than or equal, let's say 700, then I want to move right 5 pixels. And we're going to do that for all the other ones as well. This is going to be W, so it's going to be up. So if my Y axis is greater than or equal to, I'm going to do 300, and I'm going to tell you why in a bit. I'm going to do 300. If I'm greater than 300 pixels, then I should be able to continue moving up. If not, then it won't move. And then another elif statement here, if direction is equal to S, if my Y is less than or equal to 700, self.rect.y plus equals 5. And let's check this out. Oh, I didn't even connect the keys. I have the movement, but I have not done the keys. My bad. So if I'm moving to the right, if I press, if I'm moving to the left, if I press my A key, then I should be able to call on my spaceship, self._spaceship, pass in a direction, and it's going to be the A direction. And I'm going to do that for everything else as well. This is going to be for my D key. And this will be for my W key. And for my S key. Now this should work. Spatial object is not callable. What? Line 31. Why? Oh, I didn't use dot move. I'm sorry. Dot move. I'm not even calling the method. Did no one see that? Dot move. All right, I have to call the method of actually moving. Run this. There we go. So here, I don't move too far off the screen, but I don't want to just touch it. It would make it too weird. And then for the up, I don't want to move past a certain point. If you guys remember specifically with Space Invaders, I guess it depends if you're playing some generic version, kind of like the one we're making. You're able to move all the way to the top of the screen. But I would hate if I create a game and some loser tries to spawn camp the alien every time it spawns, right? So I don't want to let them be allowed to move all the way to the top from where the aliens are spawning and just shoot nonstop, right? That would kind of defeat the purpose. So I'm setting a limit here to keep the player from going too far out, to the left or to the right from wherever the aliens spawn, and ruin the fun for me. So that's why I'm doing that. I kind of want to change the limit on how far down I can move, because right here, as we see, when it starts, it's at the very bottom. But once I move out of there, I'm not able to move back down there. So let's go ahead and change the bottom part let's say 740. Oh no. Let's see how this works. Too far. 720. And you kind of have to play with it, right? Ooh, almost there. Almost there. Go with 717. It's not pretty number, but there we go. That's perfect. The pixel is 717 for mine. But that should do it. This is fine enough. I don't want to touch the window there. But here we go. We finally have some movement on our character. Isn't that cool?
I've got mine set. Yeah, that's
Is
awesome.
everyone up to speed on this? Who does not have a moving spaceship?
I'm still working through connecting the keys to the actual like movement.
Okay, I'll give you about 2 minutes before we move on with the lecture, because I would hate to have anyone fall behind.
Oh, there
Yo,
we go.
that is unfortunate.
Sorry, man. I just noticed that now. So.
Oh, that is so unfortunate.
I don't know how long because maybe someone shared screen and you stopped recording, but I think it might have been from our last break. So
I think it was from a long time ago. I think it was like an hour ago.
okay.
Eesh.
Well, I caught it now at least. Sorry about that.
Oh,
I should have caught. I
for
could have
anyone
caught it
watching-
earlier.
Honestly, dude, I think what you should do from now on, if you're open to suggestion, is maybe just like write down when we go on break. That way you can just record the whole meeting and then edit it.
Yeah,
Oh, wait, you said
I'm
it's
just not gonna
automatic.
edit
Never
it.
mind. Never mind.
I'm just not gonna even edit it. I'm not gonna stop recording. I feel so bad. Yo, whoever's gonna watch
It's-
this video, Cody's gonna watch this tomorrow and he'll be like, yo, what the heck? Yo, where's all this footage from?
Where did it's like 100 lines of code just comes out of nowhere.
Cody, if you're watching this, we created a bullet class. Figure it out, man. I'm sorry. I forgot to record. Here's the bullet class. And then in your main.py, you're gonna have to create a sprite group that's gonna hold all the objects of your bullets. And then you have to create an event type to track the mouse button down. So we can shoot this bullet every single time that we press our mouse button. This is what it looks like. You don't need this print function or this print method. Yeah, and we don't need this. But this is what the mouse button code is gonna look like. And then afterwards, make sure you draw it on the surface with the update method. All right, this is what it looks like. Yeah, my bad, Cody, and everybody else watching. But that's what happens when you're not showing up to class. Oh well. Okay, moving forward. So we just created our bullet class. Honestly, if you did miss out on the bullet class, the next class is very similar. So if you can follow along with the alien class, you should be able to replicate that with the bullet. So for the alien, we're going to go ahead and create another file, or just create that class in the same file if you have issues with your stuff, and call it alien.py. Now, within your alien class, go ahead and import Pygame. We're going to create our class called alien. And just like the bullet class, we're going to inherit from the pygame.sprite.sprite class from Pygame to be able to inherit the attributes of creating a sprite group and using the update method on the entire sprite group. That will allow us to update the movement and status of all our alien sprites without having to manually code it every single time that we want to update a single alien, right? At one point, we might have like 50 aliens on our screen, and it would be kind of annoying to have to make sure that every single one of those is being updated individually. So this will allow us to bypass all that code. We're going to initialize it. And the sprite class is going to take no parameters. And you'll know why in a bit. Now, we still have to initialize the parent class. So Pygame dot sprite dot underscore init, and then pass himself. Right, this will initialize the sprite class. Now, if you guys see into your assets, there's more than just one alien. We have a green, red, and yellow alien. And we're gonna want to use all three to add some diversity to our aliens, right? So we're gonna create 3 different data members. One for green alien, one for red alien, and one for yellow alien. How and what order you do it does not matter. Just go ahead and fill them out. They're gonna look as so. Self.green alien is equal to pygame.image.load, right? Because we have images for these bad boys, so we're just gonna go ahead and load the image, and then I need you to get the file path for that specific alien. So we have green alien. Let me copy this, put it in there. And then do that for the other ones as well. Now, cool. I have all 3 data members, green, red, yellow, alien. Now, I'm gonna create a list where I'm gonna put all 3 of these images in. It's gonna be called self.spawnable aliens, whatever you want to call it, list of aliens. I'm calling it spawnable aliens. It don't matter. Essentially, you're just creating a list that's gonna hold all 3 of these previous data members. Why is that? Well, I want to be able to cycle through them, right? And this will allow me to kind of go through all 3 of those individually, and grabbing them by their individual index, right? So green alien, red alien, yellow alien. After I create these spawnable aliens, I'm going to actually create the image variable. If you guys remember from the bullet class, I said that the sprite class is looking specifically for the name image. So we're gonna have to create the image data member. So self.image, and then the image that's gonna be given to this will be given at random. So we're gonna do self.spawnable aliens, and then guess what we need to import?
Math. Or,
Import random. Math is
Oh.
for I believe something else. We're gonna import random, right? That's going to allow us to use the random.randit method. So within here, within the brackets of the self.spawnable aliens list, type in random.randint, right? The method, and then we're gonna start it from 0 and to 2. Right, so return random integer in range of A, B, including both endpoints. So it should return to me either 0, 1, or 2. So whenever this alien object is instantiated and it runs line 12, every single time it creates a different alien, it's always going to be something different. Either one of those 3, right? That way I don't have to alternate. That's kind of lame. I would like it to be random. So the random module will allow us to do that. After the image is created, we're going to do self.rect like before, right? We want to create the rectangle. And then it's going to take the image dot get rect, and then we want to manipulate, let's say, the center, right? We're going to say the center. Now, cool. We have our alien. It has the image it's supposed to have. It has the rectangle. And now we are actually able to do something with this. Why did we not create a surface like the bullet class?
Because we have an image already, so we just need to draw it to the space service.
Correct. We're gonna draw it on the space surface, right? Unlike the bullet, which we didn't have an image, we had to create a whole shape. We needed a surface for that shape because we had to create it. But because we have the image, this image is just gonna go on top of the space surface. It doesn't need to have another surface on this, right? It's gonna work just like the spaceship. It'll be on the same layer, right? So pretty cool. So now that we have that on the alien, we're gonna go back to our main.py. And just like we did on the all bullets class, we're going to create a sprite group for all aliens. Self.all aliens. We're gonna do pygame.sprite.group, right? This will initiate a group of sprites. Once again, this is a dictionary that returns to us objects of different aliens. And here is the tricky part. Unlike the bullet, we don't want to create an alien every single time we click our mouse. We want it to spawn at a certain time. Well, just like there's the events, like when we click the quit button or when we press down the mouse button, we as users are able to create our own events, stuff that we want to happen, right? To do that, underneath the aliens, we're going to do something called timer event, right? We're going to call it self.enemy spawn timer, right? This is the event we're creating. To create an event, you're going to have to use a method. This is straight from the documents. Pygame dot in all caps user events. Now, straight from the documents too, you need to do a +1. You're essentially, I don't know how it works, but if we don't put the +1, it won't recognize it as the event. You're pretty much telling Pygame, hey, I'm adding a new event that does not exist. So you need to add the +1 into this user event. I'm not quite sure how it works, but just know that you need to do a +1. Okay. Now we're going to set a timer. We're going to do pygame.time.set_timer. Right, this will start an internal clock that you can't see yourself, but it'll start once we run the game. And then within here, what do we want this timer to do? I want it to trigger an event. And the event that it's triggering is the enemy spawn timer. Or I guess it would make more sense if you name this enemy spawn event, so you don't get confused. Enemy spawn event, right? We create the event, then we create a timer. We pass the event that we want to trigger, and then how often do we want to trigger this event? It's in milliseconds, so we're going to put 500 milliseconds. Okay, how do I know it's milliseconds? You can see the little message that comes out. It tells you the syntax of the method it takes. It's milliseconds, right? It's an integer. So this timer is going to start running and is going to trigger every 500 milliseconds. Cool. Now, we created our event type. Now, we need to actually do something whenever this event happens. So, just like we check for all these other events, we're checking for the quit event, we check for the mouse button event, we're going to check for the event we just created. We're going to do if event.type is equal to self.enemy spawn spawn event. It's going to check if the new event we created, if it happens, then what are we going to do? That's pretty straightforward. We're going to create an enemy. We have to spawn an enemy, right? This event is what's going to trigger the spawning of our aliens. So as we loop through and we're checking all the events, this is technically going to happen every 500 milliseconds. So every 500 milliseconds, I want to do something, which is spawn an alien. So we have to create an alien object. All right, so alien object is equal to alien open and close parentheses. I need to import it. I haven't done that. from alien import alien. Right, this allows me to create an alien object. Now, what do we do with these sprites? If you guys remember from the bullet, we have to add it to the all aliens group by using the .add method, and then pass in the new object we created. Right, that creates our alien object. And then, just like the bullet, it's created, they're in groups, but we need to draw it. So we drew our spaceship, we draw our bullet. Now we need to draw aliens. So self dot all aliens dot draw, and then where do we want to draw it on? The space surface. Right? So if everything went well, I should be able to press run, and we see at the very top left my aliens spawning. Now they're not doing anything, there's no functionality. I'm just creating them and pasting them at this location. Right? They're kind of overlapping themselves because that's, you know, they're being pasted, but I'm creating new ones, constantly just stacking them on top of each other. Cool? Is everyone up to this part?
I need to see the code to go over it again.
What part of the code?
The drawing.
Yeah,
Self dot
so-
aliens dot draw.
Yep, very similar to the all bullets. You draw it the same
Okay.
way.
Right.
Only thing that bullets has right now that our alien doesn't have, it's an update method, but we're about to create that before we call for the day. Cool? All right, so now we want to add some functionality to our alien. Well, we can use the update method, right? Just like the alien, it's part of the sprite group, so we can update the alien every single time on its own. So back to the alien class, we're going to define update self. And now we want to see, if you guys remember back to Space Invaders, what is the logic of the aliens? Well, they tend to start from the very top, they move all the way right, and then once they reach the right, they move down and they start moving left, right? You guys remember that? Well, we need to find a way to figure out how to do that. So we're going to create a new data member called self.going_right. And we're going to set this to true. Why? Well, because when they first start off, I'm going to spawn them at the top left, and they should move right off the bat. Normally, I give this assignment to you guys as a breakout time, but we don't have too much time. And I know if we end it here, you guys will probably just do it on your own anyways. So we'll just go over it. So on the update, we're going to do if self.going_right is equal to true, then I want to move the x-axis of the alien to the right. So I will do self.rect.x plus equals, we'll do 5. Right? But what happens if I reach a certain limit? Well, if self.rect.x is equal to 760, right? If it reaches that far right wall, then I want it to do something. If it reaches that far right wall, I'm going to increase the y-axis by 50 pixels, and that should shift it down. Right? Next is if it reached that far right edge, what does that mean? That means it's not going right no more. So I should set going right to false, right? Because I'm no longer going right. Back to my if statement, that turns false, so that means the next time this runs, it won't hit this code. So else self.x or self.rect.x, it needs to move left now, right? Because I'm no longer moving right, I'm now moving left. I need to change the x-axis back to the negative so it starts moving to the left. So essentially, I just reverse the functionality of what going right did, so I can move it left. And just like the going right code, if I reach a certain point, I want to move down. So if self.rect.x is equal to 0 pixels, then I want to shift down again. So we'll increase the y by 50. And then that means if I reach the far left, that means I'm going right again. So self dot going right is equal to true. Right? I now have an update functionality on my alien. So coming back to my main.py, after I draw them, I'm going to call self.aliens.update. And that will update every single alien within my sprite group. If we did this correct, we can press run on the main.py and we see movement. You see here, they go all the way to the right. It reaches a certain point. It increases the y-axis, which shifts them down. It turns going right to false. So now they start going to the other else block, which shifts the x-axis to the negatives. It reaches the 0 coordinate, therefore going right becomes true, and I shift the y coordinate plus 50, so it moves down and just keeps doing that over and over again. Cool. All right, I'm going to go ahead and stop the recording. This is going to conclude today's lecture and for the rest of the week. Let me stop recording.